Good evening, everyone. Today I'm excited to present our project, a banana ripeness classifier that uses artificial intelligence and computer vision to determine the ripeness of banana, whether it's fully unripe, fully ripe, or somewhat in between. This tool can be accurately classify ripeness and visualize the result. The purpose of this project is to address a real-world problem determining fruit ripeness efficiency, and this can be useful for farmers, grocery stores, or even supply chain management. This project combines a machine learning model with a fallback color analysis method for more accurate results. In this presentation, I'll walk you through. Number one is how the system works. Number two is the key components of the code. Number three is a live demonstration of a tool. And finally, some insight about its limitation and future potential. This project follows a step-by-step process which you can see in this flow chart. Let me briefly explain each step. So, the input is a photo of banana taken under the normalizing condition. The image is resized to 128 by 128 pixels normalized and prepared for the machine learning model. We use a pre-trained neural network model to classify the image into two categories, which is the ripe and unripe. The model outputs probability for each class. If the model is overly confident, for example, saying the banana is 100% ripe when it clearly isn't, the system uses a pixel-based analysis. This examines the image colors to estimate the ripeness level. The final result is a percentage breakdown of ripeness and unripeness displayed on the image itself.
So here in banana file contains the pictures rather that that are used to train our machine data model. So here in unripe and the ripe file contains a mixture of both rotten and ripe banana. And here in unripe contains also a pictures of unripe banana. And yeah, so we use this image to train a neural network model. During training, the model learned to recognize the patterns and features that correspond to each ripeness level. Using this label dataset, the model became capable of predicting the ripeness of banana in terms of probabilities for each class. The model trained on this dataset now serve as the backbone of our banana ripeness. It can accurately predict ripeness levels and visualize the result on the input image.
Code walkthrough. Now, let me take you through the key parts of the code. First is the model loading and prediction. Highlight this model. This is the load um, and save model, and this is the folder containing the test images. So, using TensorFlow load model function, this model has been trained to classify banana ripeness. So, next is this pixel-based fallback. If the model's confidence is too high, the system falls back to a pixel-based method. Here we analyze the green and yellow color ranges in the banana images using HSV or hue saturation value color space. Next is the visualization. This is for the visualization. The ripeness and unripeness percentage are overlaid on the image using OpenCV. This combination of machine learning and pixel-based analysis ensures accurate predictions even for tricky cases. So let's do a demonstration to see the code in action. So let's start with first example, which is unripe. Let's get this cut and paste it in R, test image, and run the code. So it has a ripeness of 2.46 and unripeness of 97.54, which is correct. So let's go with example number two, which is a mix of green and yellow to see how it to see the result of it. So cut it, this, go with it, and this, and run the code. Yep, the ripeness of this one is 93.49 and the unripeness is 6.51%, which is correct since this banana is turning into ripe. So that's why it has a higher percentage of ripeness compared to unripe. So next image is this. It has a ripeness of 11.07% and unripeness of 88.93% since it detects that some bananas are turning into ripe. So that's why it has a ripeness of 11.7%. So let's go with the third example, which is a fully yellow banana. Get this and paste yellow. So just get every yellow picture. Paste it here and see. So let's run the code. So yeah, it detects ripeness 100%. This one is rotten. So the next picture is ripe, also 100%, which is correct. Yep, this is also correct. Ripeness is 100%. And another yellow banana or a ripe banana, which has a ripeness of 99.87 and unripeness of 0.13, which is correct. And this one is perfectly yellow, so that's why it has a ripeness of 100%.
So, thank you for taking the time to learn about our banana ripeness classifier. This project demonstrates how combining machine learning with a traditional computer vision techniques can solve real world problems efficiently. To recap, we've walked through how our tool works, starting with an image input, pre-processing, and prediction using a trained neural network. For added accuracy, we've integrated pixel-based analysis to refine results. The system outputs clear percentages of ripeness and unripeness, which can be used in industries like agriculture, retail, and logistics. That's all.
While this system works well in controlled environment, challenges like complex background or inconsistent lighting remain areas for improvement. In the future, incorporating segmentation or multi-class ripeness detection could make the tool even more robust. Projects like this highlight the potential of AI in everyday application. I encourage you to think about how much solution to be adapted to other use cases, whether it's for fruits, vegetable, or entirely different products. Once again, thank you for allowing us to share this knowledge with you, and that's all. Thank you.